Hello time travelers, the adventure continues. Nothing is resolved yet. Let's see what awaits us in this adventure. In the previous video, we traveled and understood the Big Bang Theory. But what if I told you that not everything in this theory is complete? For example, you go through the first piece of domino, they all fall until the last one is knocked down. So that all the pieces have ended up thrown. The ones in the middle have had to transmit it, serving as messengers. This transmission has taken a certain time. The same situation happened for the temperature. The sun, for example, uses the rays of light to heat the earth. Thus, for two distant bodies to balance their thermal state, they have to use a messenger. This messenger also takes time to transmit heat. According to the theory of relativity, light is the fastest possible messenger because nothing can go faster than it. In the universe, we find that the temperature is the same everywhere, which means that the light had to have traveled to the most remote parts of the universe. The question is the universe old enough to have been able to equal its temperature? The answer is no. If we measure the distance of the observable universe, we see that from one extreme point to the Earth, the light could have taken about 46 billion years to reach the opposite extreme. So that it could do so, it could have to spend another 46 billion years. Then, how is it possible that both ends of the universe have the same temperature if they have never been in contact? One of the possible answers to this question has the name of cosmic inflation. This theory was first proposed in 1981 by the American cosmologist Alan Guth. Likewise, Andre Linde, Andreas Arbich, and Paul Stringhart made modifications to Wood's initial proposal to give it its most modern form. But what does this theory tell us? To understand it better, we will use an example. Imagine a de-inflated and compressed balloon as the initial shape of the universe. Right, at the initial moment being so small, everything is losing content and everything has the same temperature. But as the universe expands, each part would evolve differently, each one with a different temperature. What we have is a completely different universe than the one we have today. What the theory of cosmic inflation proposed is that just a fraction of a second before the initial moment of the universe, it is expanded with a speed greater than that of the light, which caused all parts of the universe to have had the time to communicate each other and reach the same temperature. But how to explain this if nothing can go faster than the speed of light? Well, for your peace of mind and that of the genius Einstein, we could not be violating law because this theory proposed that the most of the surface and space, none of the objects in the universe has a speed greater than light. This expansion of space above the speed of light is compatible with Einstein's model of general relativity. Like any scientist theory, it involves with new evidence. This is one of the answers to many questions that still remain to be resolved. As you will see, my friends, nothing has been said yet. Let's continue with more adventures. The Big Bang Theory, together with the Inflationary theory, a topic that we have just reviewed, suggests that as there is an explosion, the universe expands and forms over time. This is if we are in an open universe, which that observation point to but now suppose the case that our universe has not an open one but a closed one. What will happen? What would the end of the universe be like? Is there an answer for that? Well, luckily if we have that. That is the theory of the oscillating universe. At some point it had already occurred to someone. Well, those who were wondering, let's go back some time. In 1934, the American mathematician and physical chemist Richard J. Stallman proposed this cosmological theory, which combines two theories, of the Big Bang and of the Big Crunch, resulting in a cyclical universe, which has no end and has different epochs during its process. To understand it better, let's remember gravity. This law is what attracts objects in space to each other. That's why our planets orbit around the Sun, our solar system orbits around the center of the Milky Way, and that's why our feet they remain on the ground, and that is also why an apple falls. But I ask you a question. If the attractive force of gravity were to one day overcome the pushing force of the Big Bang, would everything contract again? This is what the Big Crunch theory tells us. In the case in which we would live in a closed universe, the expansion phase, which corresponds to the current state of the cosmos, would be followed by the contraction phase. Specifically, this contraction would cause the galaxies to approach each other, thus causing the density of the universe to gradually increase, making us arrive again at the beginning, at the point of the original atom. What the oscillating universe theory suggests is that a cyclical process takes place again and again, the Big Bang and the Big Crunch, and repeated continually for eternity. That's right, my dear time travelers in space, we have reached the lastest contributions of our era. Every theory is a hypothesis, and we have reached conclusions based on what we have been able to imagine, recreate, and observe with the contribution of the technology discovered so far. This is a short farewell. We have to open our minds and look at the world around us. Space awaits us. Maybe one of us will postulate a new theory. In our next video, we're discovering the universe, and maybe this video is not the end, if another beginning. Until the next start, remain to be resolved. As you can see, my friends, nothing has been said yet. Let's continue with more adventures.